New day and another laptop that needs to be saved, and this time we have an Alienware 13-inch gaming laptop. This is a pretty rare type of laptop, and this customer said that the laptop was completely dead, so he took it apart to change out the DC jack and also put some new thermal paste on the CPU and GPU. But when he put it back together, it actually did make some sort of screeching noise on the DC jack, but the laptop still is dead completely. So I haven't taken a look at this yet. Let's take a look together and see if we can get this figured out. All right, this is a pretty interesting type of laptop. So Dell made these 13-inch gaming laptops for a little while. This is the 13R3. This is an older machine, but it looks like he recently upgraded the LCD screen to the OLED version. But let's see if it turns on. And we're getting no power here. Let's plug in the DC jack and see what we're getting on the power meter. So keep an eye here on the power meter. And so we are pulling 0.01 amps, and then it goes down to 0. That's actually a pretty good sign. That means that we probably don't have a short on the main power rail, but the laptop still isn't, powering on automatically. Let's see what happens when we hit the power button. And we're actually pulling an amp, 1.46 amps, 1.54. Okay, so we are actually pulling some sort of amps like it's trying to come on. So let's give it some time and see if we do get a picture on the screen. Now we want to pay attention to the boot cycle here. If the current is constantly moving up and down, then we know that the laptop's actually trying to do something. Right now, it's just kind of ramped up to I just saw the Alienware screen for a second. What? So he said this thing was completely dead. It was making some sort of screeching noise. I'm wondering, oh my gosh, look. The machine's working. Okay, well, that was a quick one. I'm wondering if his charger's bad. Let me just run Diagnostics real quick. I just want to make sure it passes everything with my charger. And then we can test his charger and see what it actually does. All right, we are getting an error saying that the battery is not installed, so maybe the battery's not even plugged in. We also are getting an error that the hard drive or the SSD is not plugged in either. I'm going to continue testing. I want to see if the fans are working. I want to see if it actually is detecting the charger properly. All right, so it's passed all those tests. The fans are working fine. Let's take a look at the charger and see how it's detected. Okay, so if we were looking here, this menu should show us what the charger is being detected as, but it's not showing us anything here on this part of the menu because the battery's not plugged in. When the battery's plugged in, you'll have another section up here at the top that shows like the battery condition, what its charge state is, and then it'll also show the charger plugged in the machine, what wattage it is, how much current's going in the battery, going in the machine, things like that. But so far, everything looks fine to me. Let's open up the bottom and see if we can reconnect the battery, and then we'll continue testing. Now this laptop is a lot older machine. I'm trying to think of what year it would be. Probably a 2016 is what I'm guessing. The customer already upgraded the LCD screen to the OLED. I mean, and this machine's in great condition. So I'm wondering when this customer actually started exhibiting some issues, and then I don't know what all he's tried, but I guess just changing out the DC jack is what he's tried because that's the only thing he listed in his notes. But that would be kind of interesting if it ends up just being a charger issue, right? And of course, I'm not going to be charging him any labor or anything for that. All right, yeah, look at the bottom. It's beautiful. Brand new, clean. It almost looks like it's a very new machine. So battery is unplugged. We can take a look here. So I'm just going to plug the battery in. Now, we may have an issue when the battery's plugged in because we could have a shorted MOSFET on the charge circuit, and that will cause an issue when we plug in the charger. So again, let's keep an eye on the power meter here. And when I plug this back in, let's make sure that it does not shut off the charger. We're just going to wait a second. If it triggers charge current, then we should be good to go. Otherwise, it will trigger charge current and shut off the machine. 0.01, we're going to wait a second. It should jump up to 0.2 and then start charging the battery. And it's not doing it. So this battery could be so low in voltage that it's not trying to trigger. Let's boot into Diagnostics again and take a look. If you're wondering why the screen looks like this is a film that's protecting the screen because he just installed this. All right, we're back in Diagnostics. I'm still not showing the battery in here, so the battery's probably so low and depleted that it's not even detecting the battery. Let me see if I have a test battery somewhere. This is an older machine, but I should have a test battery, so I'll be right back. All right, got a test battery. Because we specialize exclusively in Dell and Alienware laptops, we have pretty much every single machine that Dell's ever made back there in our warehouse with about 700,000 parts. You can purchase any parts you need, but I'm just gonna plug in our test battery here and see if this one shows up and starts detecting and starts charging. We're trying to determine if the motherboard has an issue or if it's just their charger. But first I wanna make sure, because we're gonna plug in their charger in a moment, but I just wanna make sure that this is all working first with our equipment. All right, the battery's plugged in. I'm just gonna keep it this direction for right now. Let's just plug in the charger, see if it starts pulling that current. So you see it jumped up to 0.05 that time. Let's see if it jumps to 0.2 and starts charging. 200 milliamps is going to be the pre-charged current where it kind of negotiates with the battery. We can also measure the voltage on the terminals here. That might be a good thing to figure out how many volts we actually have. Now let's get under the microscope. All right, so here's the battery connector. So we're gonna have on one side, we're gonna have a set of positive pins, and the other side are gonna be the negative pins, or ground. And so I have my meter in voltage mode. I'm just gonna measure across here. This battery also does not have a charge on it. It's 0.19. Now, it could be asleep, but it had been sitting around for a while. Oh, you can actually see these three are gonna be the positive, these three are gonna be the negative, the middle are data lines. But whether I have it plugged in all the way or not, this connector, I was having a hard time getting it to go all the way in. Yeah, looks like it's all the way in. Let me plug their battery back in and see what that one does. See if it reads anything different. Yeah, this connector is really tight. Okay, so we have it all the way in. This battery will not output any voltage unless it's detecting that it's plugged in. So the way this works is we have 3 grounds, 3 positives, and then you're gonna have a data and clock line, and then you'll have an is present. And then I think the last one doesn't not connect to anything, but I think this is the is present line, or maybe this one is. And then you have to ground it, and then it will say that the battery is actually connected to something and allow the voltage to flow. So we're gonna measure it again. Okay, now you can see it's at 0.81 volts on the battery. And I'm gonna see if it drops back down after a second. It's just staying there, now it dropped down by itself. Okay, so it looked like it was trying to negotiate and trying to actually use the battery, or trying to wake up the battery, and it didn't want to. So our test battery is probably depleted also, but let me plug it in and we can do a fresh measure. So right when we plug it in and then measure, it measures a different voltage than what it is after it sits. So right when we plug it in, let's measure it. So this one's still completely dead. Let me plug in the charger while we have it in here. Yeah, so our battery's dead, their battery's dead. The thing is that these machines are so old, is that these things have been sitting around. I mean, this battery is in brand new condition. We always buy these machines new, and but it's just been sitting around, hadn't had any charge in it. So let me hook this up to my NLBA battery tester, and let's see if we can wake this battery back up. All right, here's my NLBA, which is the battery analyzer. I plugged our test battery into this, and I have the app pulled up here, and if I'm reading it, you can actually see that one of the cells are actually below value. So it's below 3 volts, like the thing just shut off. So let me power it back on again. And this will allow me to read the battery's BMS. And let's see if we can get a reading out of it. Let it sit there for a second. But it was showing that one of the cells was low and that it locked the battery. So that means that this battery is bad. There's nothing we can really do about our test battery, but let me hook this up to their battery and see if we can wake up their battery. All right, so all I need to do is just connect this to their battery. All right, I have the battery connected to the battery analyzer, and let's see if we can start reading it. And it's not reading anything when we press the button, so we'll have to actually power on the BMS by manually injecting voltage onto those data lines and see if we can get a reading out of there. Sometimes it takes a second for it to actually energize. And their battery's not reading anything, no matter what I do. I'm gonna let it sit here for a little bit and see if we can get it to partially charge. But their battery may be completely depleted too. Unfortunately, this machine's so old that you can't really replace the battery with an OEM because the Dell hasn't made them in a long time. I don't have any in stock. I haven't had any for many years. So this would have to be like some sort of aftermarket battery. But I'm gonna keep testing. I'll be right back. Okay, I got their battery communicating after letting it sit, and it looks like it's in a unlocked state. It's balanced, so it is ready to go. So we got to figure out why the machine is not detecting it and charging it. So that would be the next thing to check. Let me charge it up a little bit while we have it in here and see, maybe it just needs to be at a higher charge. 3.6 is actually storage voltage, so that's fine, but the current charge state says 3%. I'm gonna go ahead and just charge it a little while on this app, and then that way it's already ready to go when we plug it into the machine. All right, so I've let this battery charge up for a little while. Let's plug it in and see if the machine will power on off of this battery, because we know the battery's good now. We know that it has a charge, so the machine should power on off of it. And I am getting a keyboard backlight for a second. And it turned back off. I saw it for a second. The fans are running. Let's see if we can get that Alienware screen, and we do have an Alienware screen. Okay, so it is running off the battery now. Now, is the battery detected whenever I go to Diagnostics? That's the next question. Because basically what ends up happening is if a machine sits around, the battery will end up going into like kind of a sleep mode or a sleep state, a stale state, and you have to wake the battery back up. And so that's what we did when we plugged into the battery analyzer. Now, leaving it plugged in long enough in the machine, it would have woken it up because it's basically gonna ping it occasionally. Let's figure out if this battery is fully functional and everything's resolved. We do have the Alienware light here. The BIOS isn't gonna tell us anything on this machine. That's why we have to go to Diagnostics. But it is running off the battery. I'm gonna turn the machine back off. Let's see if it starts charging. Again, we can see if it starts charging by just looking at our power meter here. So 0.01, it should jump up to 0.2, and then it should start pulling like, I don't know, 1.5 amps, 2 amps. So it's moving up a little bit. Come on, jump up. Yeah, 0.02 is not gonna do it. We need 0.2 or 0.23, somewhere around there. And then it should start charging. I don't know what's going on with it. So our charge circuit could be messed up. But I do have a light on here, almost like it is thinking about charging. Now, if you were just looking at this, you'd be like, oh yeah, the battery's charging. But see how the light's kind of fading on and off like it is charging? But we know it's not because we were looking at our power meter here. So we could still have a communication error with the battery itself. Maybe the battery is putting a positive and negative to the power rail, and then it's able to power the laptop, but the data and clock lines aren't communicating properly and it's not able to charge it. That might be what's going on. Let's boot into Diagnostics again. I have the charger plugged in. It's pulling current off the charger to turn it on. And we put some % charge in the battery, so we have a little bit of power in the battery. But what we want is to see if we have the battery being detected in our Diagnostics now. And we do. Yay. All right. So there's our next thing that we're looking at. So I could see that the battery is showing up 4% charge, 77% health. Battery voltage is there. Ooh, this is a touch screen. Oh, man, this is nice. So, but one problem I'm seeing, we have our 240 watt charger plugged in and it's sitting at idle. Why is it sitting at idle? Why is it not going into a charge state? Because it should be saying charging and then actually putting current into the battery. It's not showing that. The battery's actually depleting a little bit, is it? No, it's just staying steady. Let's try a different charger. This 240 is a newer charger than when this machine was made, so maybe it's having an issue with understanding that high of wattage. So let me grab like a, I don't know, a 150 watt or something. Or should we plug their charger in? They have a 180. It looks like a fairly new charger. It's a Dell OEM, so it shouldn't be an issue. Let's plug theirs in. And what's great about my power meter here is I can just plug their charger in the back of the power meter that I made, and you'll still be able to see the wattage and everything going through it, just the same. Look at that. So now their charger is actually plugged into the back of my power meter. We can see that it's actually pulling the current. It's detecting at 180 watts. At this point, I don't know why they sent it in, because it's turning on, it's working, it's not making any noise. The battery's not charging, but that's not something they even talked about. They just said that the machine was dead. Their charger's working. So, I don't know. Now, I mean, we're gonna have to try to address why the battery's not charging. We probably have a bad MOSFET somewhere. Maybe there's something intermittent happening. But let's look at the data lines on the battery connector, because that's what I'm thinking is actually messed up. Remember how we talked about that connector being hard to plug in? So let's see if we can look at this connector at an angle under the microscope and see if we can notice if there's any pins bent, because that happens. Okay, so let's see if we can look down in here. Okay, yeah. So you could actually see that this end pin is bent over. And if you look here, yeah, you can see that there's a little bit of damage on their connector, but this pin's not even being used out of all these. So it's kind of just a dummy pin, but is it preventing it from actually turning on or being able to plug in all the way? Is it preventing it from being able to plug in all the way? I don't know. So let's just bend that back and see if we can get this to go in all the way. Oh yeah, that went in way better. Huh, okay. Well, let's see if that resolves the issue. All right, we got that plugged in. Hey, 7 amps for a second? What's up with that? Why did it pull 7 amps for a second? Did you see that? Did you see that? 7 amps? That's too many. That's too many. So the question is, why did we pull 7 amps for a second? Whew. So a battery should charge at most around 3 amps. These older machines, I don't know if they even got up to 3 amps. Maybe 3.5 amps, that's 75 watts. All right, I'm gonna plug this in. I just wanna see what the voltage is on this line. 19 volts, that's what the issue is. You see that? Battery voltage is not 19 volts. So if we have 19 volts trying to go to the battery, and usually it shorts out the AC adapter when that happens, but it didn't do that this time. So, but we did pull 7 amps and then it shut off. So we do have some shorted MOSFETs in here. So it's gonna be the MOSFET that separates the battery from the machine. So we're gonna have to change out that MOSFET, that's gonna be shorted. We may even have an input protection MOSFET that's shorted out at this point. So let's pull the motherboard out and take a closer look. All right, we might get lucky on this one. We may not have to pull the whole board out, but let me just show you where the charge circuit is and why it's such a big deal that we're getting 19 volts on the battery connector. So the way that I want you to kind of think about it is that these machines are made to have 20 volts go in, and then they will be broken up into a bunch of different power rails, right? So you'll have a power rail that is a 5 volt, a 3.3, 1.8, 1.2. You have it where it runs the memory, the chipset. Then you'll have CPU voltage, GPU voltage. Then you have battery charge voltage. This battery is a 4-cell battery, so it's a 15.2 volt nominal voltage. So 16.4, I believe, is something like that, should be the battery voltage on the connector of the battery, but not 19 volts. So what's happening there? That just means that the MOSFET is shorted open and just sending all the voltage straight through from the charger straight to that connector instead of pulsing it. So the way a MOSFET works is you'll have 3 pins in, 4 pins out, right here. And then 1 pin is a gate pin that actually is where they pulse the voltage, and then you can turn it on and off and it will reduce the voltage down. So this should be being, oh, what is this? You can see that this one has been getting hot. There's solder balls coming out at either side. So I'm assuming that this is probably the bad one. Or it's been replaced, but I don't think it's been replaced. I think that this is actually just from heat, due to heat from charging. Anyway, what I'm saying is basically these just act as switches. They're on off, but then if you pulse it, then you can actually create a lower voltage. So that's how the battery charge circuit works. And if we're getting all the 19 volts straight over to here, then we have an issue. And I've seen this happen numerous times. But I'm assuming because this is gonna be a 4-cell battery that runs closer to 16.5 volts, that if it's putting 19 volts there, it's not freaking out enough where it shorts out the battery, shorts out the charger. Whenever you have a 3-cell battery doing the same thing, the charger will just shut off because the battery will say, hey, that's way too much. So, well, we did see it pull 7 amps, which is a crazy amount. I'm just gonna put the meter in continuity mode where when we touch the probes together, it beeps. And we have a short there. And we figured this out without even having to really, do much. This one's not showing shorted, but it is showing shorted to the gate here. So we're gonna replace both of these. Let's see if this gate's shorted. It is. So we're gonna replace both of these. We know that this one's definitely messed up. This one probably got messed up too, but let's see. This is the current sensor resistor on the main rail. Let's see, that's not shorted because well, it shouldn't be, because the machine's working on battery. It works on battery, it works on charger, put them together. What do? You get a problem. The customer said that there was getting some sort of sizzle sound. That might have been this MOSFET right here. It could have been that the battery connector wasn't all the way plugged in, but it was trying to charge, and so it was having poor connection there, but then it was sending too many volts there. So there could be a number of different things. So plan of action, replace both of those. Hopefully that should fix the issue. I'm thinking, I'm not even sure that these are the ones that go to this. But I guess we can maybe see if we can measure it here. Which side's positive? So this is the positive. And let's see if any of that goes over here. Yeah, so I don't know. There may be another set of MOSFETs on the other side, but we can definitely see that this one is shorted. So I'm going to start with that pair. And are they both the same? This is a MDU 1512, MDU 1512, so they are both the same. So let's get both of those replaced, and then we will continue testing. All right, the right thing to do here is just to pull the motherboard out, replace those, and then that will give us a chance to look at the other side and see if we see anything suspicious, because I'd rather just get it done properly and not just try to take this short way out. So let me just get the motherboard all the way out. All right, and the motherboard is out. Now we can look on both sides. We will have more stuff on the other side anyway, so we want to go ahead and look at that. And we do have more MOSFETs on this side, and we do have some more evidence of heat. So these two guys look a little bit hot. And let's see if they're shorted. This one almost looks like it's not soldered all the way. You see that? Where it's kind of floating? Let me see if I can get this at an angle. Or I don't know if it's been replaced, but see how this one looks different than this one? Now granted, it is the other side. Each side will be a little bit different the way that it mounts, but let me look at this one. Or it's like a different MOSFET altogether. That might be what it is. Yeah, it definitely is taller. I just don't know if somebody has been working on this. I mean, the board's in really good condition. The machine's in really good condition. There's not a lot of flux all over it. But yeah, you can definitely tell that that's a different chip. I mean, it has a different number on it, but I don't know. I don't know, but let's measure to see if it's shorted. Okay. That's not measuring shorted. That's not measuring shorted. We always want to measure gate to drain. That's fine. This one's fine. This one's fine. That all looks good. And then this is going to be maybe paired up with one of the ones on the other side. Nope. So that's fine. And then this other one over here. That one's fine. All right, so nothing to worry about here on this side. So it's mainly just going to be on the charge MOSFETs. Or these are probably these are actually the input protection MOSFETs. Wait a minute. Wait a minute. Okay, so voltage comes in here. 19 volts comes in here, goes through these two inductors, and then goes into this first MOSFET. This thing is shorted on, which means it's been trying to shut itself off and got ruined. So these are actually don't have anything to do with the charge, but they're actually what produces the main power rail or allows the current to flow. And so those things have been trying to protect the motherboard by shutting itself off, and they ended up getting burned out. I've seen that plenty of times. Usually it's the first one. But we're going to replace both of those. Now we need to find the MOSFET that actually is in charge of charging the battery itself, or creating that battery charge voltage, which would probably be this one then, but we just checked it and it wasn't shorted, right? It's not. Okay, well this one's shorted for 22 ohms from gate to drain. It could be that one. I got to figure out where the output is. Because wherever this coil is tied to is where we know that the MOSFET that drives that is. But there's usually a pair. And it could be those smaller ones. Could be these pair? Remember we tested these already. Tested those. Without a schematic, it's kind of hard to know. So what I'm trying to do is I'm just trying to figure out which MOSFET is stuck open or stuck on that's passing the voltage straight through. Let's start by just replacing those first two. We know that those two are bad, or at least the first one is. And by replacing those, that will resolve the issue where it is shutting off. Like the board's turning on. Now, maybe it didn't turn on for the customer for a while, but then that MOSFET shorted out and just allowed this stuff to go through. Because basically, the way it works is the power management chip will shut those MOSFETs off and not allow current to flow to the board if it detects an issue. Well, guess what? This thing got shorted to the on state, so therefore it's just sending voltage straight through. So what good is that, right? It's almost like putting a wire across here. There's basically a wire just soldered across that. And you can tell this thing's been getting hot because of the balls here. But I really need to figure out what ties to this or creates this rail. And I'm assuming it must be one of those, a pair of small MOSFETs on the other side, but I don't know. But let's get these replaced real quick. All right, so I'm just gonna put some Kapton tape over some of this plastic stuff. We're gonna blow the hot air away from everything. Let's see what angle I wanna put it in. Maybe we'll go this direction with it. Yep. So we'll be able to hear the two MOSFETs. We're just gonna blow the air this way. I'll protect this DC in connector. All right, let's get these guys removed. A little bit of flux. This board's pretty thick, so I'm just gonna let it heat up for a little while before we start pulling them off. Okay, this solder is already flowing. And we got that one off. Let me pull the other one too. And that one's off. All right, while the board's hot, I'm just gonna put some leaded solder on there. Perfect. And I don't think I have any of these MOSFETs. Let me check. I'm just checking to see if I have any of these brand new. I don't. So I have a donor board. Let me just grab a donor board and we'll just use that to replace them. All right, I grabbed the donor board from my donor board pile back here. This is actually for the 15-inch version of this same board back in that same generation. And it does have a pair of those MDU 1512s on it right here. And so we're just gonna take both of those and transplant them over. So, but if you can look at this, it has kind of the same setup. So this is actually battery and DC jack next to each other. But so we get the DC jack, we get the battery in, and it goes across here. I'm just trying to figure out exactly, I wish I had the schematic for it. I could probably look it up and see if we can find a schematic for this 13-inch board. Anyway, let me grab these and we'll move them over. All right, we got them both removed. All right, first one goes that way. All right, we got to get the second one installed now. All right, a little bit of flux so we can seat them all the way. Right now they're just kind of tacked in place. All right, so we can see this one's sitting down nice. Before I put the flux on there, it wouldn't sit down all the way. Now we have both of those nice and seated in the right position. And let's let them cool off and then we will test. All right, board's cooled off. Let's make sure their short is gone. So we don't have our short there anymore. That's perfect. And this one's still showing shorted, but that doesn't mean that it is. Let me see if I can trigger it. There we go. So at first, basically, this thing was stuck on the on state, and then you could trigger it on and off by touching the pin there, and or it might have still been hot or something like that. So now it's actually measuring fine. Let me clean that up just a little bit. A little isopropyl alcohol. All right, so we got the first thing taken care of. Now, this may resolve the issue, but I doubt it will. Usually, when we have this issue where it's sending the wrong voltage to the battery connector, it's going to be on a different MOSFET, which we haven't identified which one that is yet, but we did get one step closer. I know that it wouldn't have charged the battery anyway. Whenever we have one of these shorted on the input, usually the machine will go into a charged state, but then it won't send any current there because it detects an issue on one of the MOSFETs. But let me install the board temporarily. I just want to see if it does have the right voltage on the battery connector now. Here, I'm actually just going to take the DC jack out so we don't have to put it in this thing every single time. All right, DC jack reconnected. Plug in the charger. We are still getting our 0.01, which is good. That means that the board's getting power. All right, I'm going to unplug the charger and plug it back in to reset it, because it will go to a resting state if you let it sit on long enough. So right when you plug it in is when we can test what voltage it has. And it's just sitting there at 0.23. Interesting. So we got 0.23. I'm going to unplug the charger. So it's still staying at 0.23 with the charger unplugged, because there's capacitors that are charged up. But when we plug this back in, it should actually go to the 19 volts. Or go to the 16 volts or something. It's not doing that. Let's see if we're getting the rest of our voltages. We have our 3.3 volt power rail, and we have our 5.2 volt power rail, which is our 5 volt power rail. So both of those are up and running. Let me plug in the battery and see if we get 7 amps whenever we plug this in. So I have the charger unplugged. Pay attention to the power meter. We want to see if it spikes to that 7 amps again. .23 and 1.72. And this is not the machine on. This is it charging, okay? It's actually charging the battery now. Let's take a look here. So if we look on the battery connector, we have 15.7, and it is going up. So the battery is charging. The issue is resolved. So we did fix the charging issue. It was just those first MOSFETs. Probably just that first one, but the second one looks suspicious too. Better just to replace both while we're in here. So now we can get this reassembled. I think everything should be good to go. The customer talking about the sizzling noise, I'm assuming it was probably this MOSFET burning up or the connection with it not being plugged in properly. So we had a couple of different things we saw there. But let me go ahead and get this reassembled and we can finish testing. All right, I got their motherboard completely reinstalled. The machine is back together. Let's plug in their charger. I am using their charger, just passed through my power box here. We plug it in, let's see what we're getting. And it is pulling the 0.23 for pre-charge current, and it's at 174 for charge current. Now let's turn it on and boot into Diagnostics. I just want to see that we have charge current going into the battery and then charge current coming out. And then that should wrap everything up on this one. All right, battery is detected. It's showing that we have 6% in the battery right now. We have 2 amps going into the machine here. And then we have a 180 watt charger, says it's in charging state. I'm going to unplug their charger. Charger is unplugged. Now it's discharging at 2 amps out of the battery, so it's running the laptop off the charger. I'm going to plug it back in. And we just want to see if it switches back to the charge state, so it's at idle. Now it's discharging, and it's back up to the 2 amps. So this wraps this one up. We've fixed this 13-inch gaming laptop by Dell. This is a 2017 model. I'd love to know your thoughts on this one, and thanks for watching.
I saved another laptop.